Hello everyone. This is homework number 3, applications of percents. So your favorite word problems. And of course I'm being facetious when I say that because most students don't like word problems. But hopefully you'll see that this is not very difficult as long as we remember the main phrase regarding percent problems, which is the percent of the base is the part. And although you could use either method, the proportion method or the equation method, we showed both of those last time, we're going to show the equation method. So that's the preferred method by mathematicians. So that's what I'm going to use. And again, the key phrase, percent of the base is the part. Now we can't go with the oven is thing too much here because the wording of a word problem doesn't lend itself to adhering to that rule. So you have to make sure you understand that the percent is the rate and the base is the whole or the quantity under consideration, and the part is the portion of the whole. And that's why we say that the percentage of the base is the part, because we're taking a percentage of the whole quantity to determine that portion of that whole quantity, which is referred to as the part. So with the equation method, we're always going to start with blank percent of blank is blank. And we saw that last class. And then we're going to translate it. Remember, of means multiply and is means equals. And then we translate and solve for the unknown. So we mentioned some special notes last time about this procedure. When using the equation method, we have to change the percent, must be changed to a decimal when we translate the sentence into a mathematical equation. And then also when solving for the percent, the answer is going to be a decimal and we have to change that to a percentage. So here's some examples. First one, statistics show 12% of dog owners own 3 or more dogs. And if there are 75 dog owners are selected, how many are expected to own 3 or more dogs? So recognizing it as a percent problem, we'll write our statement, blank percent of blank is blank. Remember, the percentage is always the first thing we look for. We either know it or we don't, and it should be obvious in this case it's 12%, so we'll fill that in. So then the question would be, what does the 75 represent? And we have to think once again that the base is the whole or the quantity under consideration, and the part is the portion or the percentage of that. And so it says that 75 dog owners are selected, and how many would own 3 or more dogs? Well, the how many that own 3 or more dogs relates to the percentage of the total, which is the 75. So the 75 would be our base, and the part is the unknown. I will call it X. So once you discern that, translate to a mathematical equation. Remember, change the percentage to a decimal 2 places to the left. Of means multiplied, and so 0.12, 0.12 that is, times 75 is means equals X, and it is just a simple multiplication. So 0.12 times 75 is 9. And then formally, you should finish it up with a nice college-like sentence. We could say that, for example, 9 of the 75 dog owners own 3 or more dogs. Okay, so on to a second example. Here we have people believing in ghosts, but recognizing it as a percent problem again, blank percent of blank is blank. And the percentage again, first thing we look for, it's obvious, 45%, fill it in. And here we have to think a little bit carefully. There's 576 people, or 45%, that believe in ghosts. So the 45% represents the portion, the percentage of the whole, which gives us the 576 people. And you can even further realize that the 576 represents the part, or the portion, when you read this part of this sentence, how many people were in the survey. So that's the total number of people in the survey. That would be the base, or the whole. So the base is the unknown, and the part is the 576. Okay, and then again we translate to a mathematical sentence. Percentage changed to a decimal, 0.45. Of means multiplied by, so my multiplication symbol, x is means equals 576. I really don't need the multiplication symbol in there. I mean, you could just jump right in and divide, but I'm going to rewrite it without the multiplication symbol, because it's understood when we write 0.45x that it means 0.45 is being multiplied by x. And now it's just a basic division. So we're going to divide by the 0.45. Remember, never put the x down there. Mentioned that many times. So divide this side by 0.45 as well. And we get that x equals, obviously use a calculator for this one, so 576 divided by 0.45 is 1280. So 1280, and then again, people were in the survey. Now, my math lab really doesn't require you to write a little sentence, but it's kind of nice to summarize if you were doing this as a project for a course or a report for your boss. Then summarizing it, of course, would be part of the presentation. Alright, so a third example of a basic percent problem. Application, word problem. The family deposited a principal of $2,500 into a savings account, and they earned $93.75 interest. What percent of the principal is the interest? So blank percent of blank is blank, and now we don't know the percentage. We're saying what percent, so we'll call that x. And again, we have to think of the base as the whole and the part as the portion of that. So try to put yourself in the physical situation of having this $2,500 and you actually put it into a savings account. That's your whole. That's your quantity that you're earning interest on. And so that would have to be the base, following the of. And the interest that you earn is the portion of that principal or base or whole. So that's the 93.75 is the part. Okay, and then translate it. So x of means multiplied by 2500 is means equals the 93.75. I'm going to take an extra step to rewrite this. As we know, should always rate the coefficient before the variable. So instead of x times 2500, 2500x, and the multiplication is understood, and that's 93.75, and then just a division. So we're dividing both sides by the 2500. So the 93.75 gets divided by the 2500 as well. And we get x. And so on the calculator, 93.75 divided by 2500 is 0.0375. But when we think about summarizing this, and moreover recall that when we're solving for a percentage, that answer that we get is a decimal answer that has to be changed to a percent. So to change a decimal to a percent, well, when we change a percent to a decimal, we move to the left. So when we change a decimal to a percent, we move to the right. And remember, it's always two places. So 3.75, and we add the percent symbol. Okay, so then we get to increase and decrease problems involving percents. And just think of this intuitively. Don't make it harder than it is. If we had an increase problem, the amount of increase would be added to the original amount. And if we had a decrease problem, the amount of decrease would be subtracted from the original amount. And one thing that is very important is that the original amount, and this actually makes these problems rather easy. The original amount, no matter what situation we're dealing with, the original amount is always the base, because that's the whole, or the quantity that we're taking the percentage of. Excuse me. And therefore, the amount of increase or decrease, as mentioned in the note here, will represent the part. So that makes these problems even easier, because our sentence is always going to be blank percent of blank is what we're looking for, the amount of increase or decrease. So we'll start the same way. You can see it's a percent problem. So we'll write blank percent of blank is blank. We obviously have the 18%. And so, as it says, because of the increase in the cost of raw materials, food manufacturer raised its price on bread that originally cost $3.50. That was the original cost. So that would be the base, 3.50 or 3.5. And we're looking for the amount of increase. That's going to be X, the part. So we translate the percentage changed to a decimal, 0.18. of means multiplied by again. 350 in this case is means equal, that's x. And then it's a simple multiplication, 0.18 times 3.5, 0.63. And we're talking about money, so you might even say dollars, right? 63 cents basically, or $0.63. And note that that's the amount of increase. And they asked for two parts here. The increase in price, which we just found, but then also the new price. And so the new price, because it's an increase problem, again, just think intuitively, you don't need a formula for this. It's just taking the original price of $3.50, and since it was an increase, we're going to add the 63 cents, and the cost of this loaf of bread is now $4.13. So a decrease works the same way, as we'll see in the next example, except for the fact that we will be subtracting from the original amount. So here we have a situation where somebody goes out and buys a gas barbecue, and the lid was dented when the employee assembled it. So the manager decreases the price by 20%. We want to know again the amount of decrease and the new price. So recognizing this as a percent problem, we start the standard way. Blank percent of blank is blank. And we can fill in the percentage first, that's 20%. Remember, the base is the purchase price, basically the original price of the item, and that's the given, the $199.95, and so we're looking for the part or the portion that is going to be decreased. So again, change the percent to a decimal, so 0.20. Of means multiplied by the $199.95 is means equals, and that's the part or the portion, the amount of decrease. So on the calculator, 0.2 times 199.95 is $39.99. Okay, so that represents the amount of decrease. And so now we want the new price. And the new price, again, just think intuitively, it was a decrease problem. So subtract that amount of decrease from the original price of $199.95. So then subtract the $39.99. Probably use a calculator for that as well. And we get $159.96. Okay, so I'm going to stop right there and make this video in two parts. We just need to talk about sales tax and commission problems next. So we'll come back and finish that. And then that will end the material for the first exam.